Okay, so this is the next lesson in Algebra 2. The lesson is called Solving Quadratic Equations with Square Roots. Okay, so just a quick square root review. Remember, taking a square root is the opposite of squaring a number. And you're going to need to know these perfect squares. Okay, try to memorize up to 225 at least. Perfect squares are made up of multiplying whole integers by themselves. So for example, 1 is a perfect square because it equals 1 times 1. 4 is a perfect square because it equals 2 times 2. 9 is a perfect square because it equals 3 times 3, and so on. 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on. Okay? So example 1a, we're going to solve this for x. We have x squared equals 25. So what we are going to do is we are going to take the square root of each side. And when we take the square root of the right, we're going to take the positive and negative square root. Okay? So now on the left, the square root of x squared is x. So we just have x equals positive and negative square root of 25. Okay, because the square root of x squared is x. And now let's simplify the square root of 25 down to 5. So that's the final answer. X equals positive and negative 5. So you may see some questions like how many solutions are there to this problem. This problem has two solutions, two real solutions, positive 5 and negative 5. Two real solutions to that equation. Okay, 1b, same thing. Take the square root of each side first. Square root of x squared equals positive and negative square root of 81. The square root of x squared is just x. So it's x equals positive and negative square root of 81. And then you want to simplify the square root of 81. And 81 is a perfect square. So when you take the square root of it, you just get 9. So x equals positive and negative 9. Okay. So this problem has two real solutions, positive 9 and negative 9. Okay, 1c, x squared equals negative 144. First, again, take the square root of each side. So square root of x squared equals positive and negative square root of negative 144. Square root of x squared is just x. You can skip some steps if you feel comfortable. And again, I'm going to break up square root of negative 144 into this. I'm going to say x equals positive and negative. I'll do square root of 144 times square root of negative 1. And now we'll simplify each of those because the square root of negative 1, if you remember back to lesson 1, we're going to write that with an I because I equals the square root of negative 1. And the square root of 144 is 12. So when I solve this, I get x equals positive and negative 12i. So if I were to ask you how many solutions are there to this problem, there are two solutions, and they're not real, they are imaginary solutions, they're called. We have positive 12i, and we have negative 12i. So this one has two imaginary solutions. Okay, part D, solve that. Take the square root of each side. Positive and negative on the right. So x equals positive and negative square root of negative 36. I won't skip any steps. So next I'll do x equals positive and negative square root of 36 times square root of negative 1. Square root of 36 is 6. And the square root of negative 1 is I. So x equals positive and negative 6i. So that page wasn't too bad because everything on that page was a perfect square. The next page, that is not going to be the case. Okay, so let's move on to example 2. And you'll see solve x squared equals 18. 18 is not a perfect square, okay? Again, I'm talking about these numbers right here. These are the perfect squares, okay? You need to have those memorized because we're going to use them going forward. in this lesson and the next two lessons. Okay, so again, first step, take the square root of each side. Positive and negative square root on the right. So x equals positive and negative square root of 18. Again, you might be able to skip some steps. But you need to simplify the square root of 18 using the list of perfect square numbers on the front page. So which perfect square is the factor of 18, if there is any? And if there is, try to find the biggest one. So pause the video if you need to, but it's going to be 9. So it equals square root of 9 times square root of 2. So that's my next step. The square root of 9 is 3, so x equals positive and negative 3 square root of 2. Again, the number goes before the square root part, and the positive and negative symbol comes first. So x equals positive and negative 3 square root of 2. That's how you have to write the answer. Okay, similar thing for example 2b. Take the square root of each side. Positive and negative on the right. That gives me x equals positive and negative square root of 24. And then simplify the square root of 24 from the list of perfect square numbers on the front. Pause the video if you need help, or if you need to do it on your own first. But you're going to get 4. 4 is the biggest perfect square of 24. So 4 times 6. And the square root of 4 is 2. So x equals positive and negative 2 square root of 6. Part C, same thing, but now it's going to be, you're going to have I. So take the square root of each side. Positive and negative on the right. So it gives me just x. So now what you're going to do is you're going to simplify the square root of 40 with the list of perfect square numbers. So 4 is a number that's a factor of 40. So check this out. I'm going to write square root of 4. Then I'm going to put square root of 10. And I'll put square root of negative 1 like that. Okay? Now the square root of 4 is 2. And the square root of negative 1 is I. So 2I square root of 10 in positive and negative. That's how you write the answer, okay? So it goes number, then I, then square root. And positive and negative comes out front. Okay, 2D is a similar problem, so you might want to pause the video and try it on your own first. Okay, so square root of each side. Positive and negative on the right. X equals positive and negative square root of negative 125. And now see if you can find the biggest perfect square that's a factor of 125. It's going to be 25. So I'll write square root of 25 times square root of 5 times square root of negative 1. And the square root of 25 is 5, so x equals positive and negative 5. That became 5, okay? And this becomes I. So 5I square root of 5 left over. Okay, so that's example 2. Next page just has a couple of, multi-step equations. So it says solve for x. So in order to solve for x, you have to solve for x squared first, okay? So first, solve for x squared, and then solve for x, okay? So if I want to solve this one for x squared, I'm going to subtract 100 on each side. So I get 4x squared equals negative 100. Okay? Then I'll divide each side by 4. So x squared equals negative 25. And then what I'm going to do is I'm going to take the square root of each side. Okay, take the square root of each side. So if I take the square root of each side, here's what I get. Okay, I'm just going to go right to x. Okay, because the square root of x squared is just x. So if I take the square root of this, I just get x. Square root of this side. If that's too much, I guess I'll write out that step, just in case it's too confusing. I took the square root of each side. Okay, took the square root of each side. So now I get x equals positive and negative. Square root of negative 25. Square root of negative 25, if you want to think about it like this, it's x equals positive and negative, square root of 25, square root of negative 1. So it's positive and negative 5i. Again, I didn't skip any steps. I was originally, but I chose not to for this. So if you wanted to go, you could probably go right from here to the answer if you feel comfortable doing that. Okay. Part B, solve this for x. First solve it for x squared, so subtract 48 on each side. X squared equals negative 48. Now I'm going to take the square root of each side. Positive and negative on the right. So x equals positive and negative. Square root of negative 48. And now you have to simplify the square root of negative 48 using the list of perfect square numbers on the first page. And the biggest perfect square, that's a factor of 48. Again, if you have to pause the video and try it on your own, do that. It's going to be 16. So I'll write it like this. Square root of 16, square root of 3, and we still got the square root of negative 1. So square root of 16 becomes 4. Square root of negative 1 becomes I, and the square root of 3 stays. Okay. So again, all these questions, if I were to ask you how many solutions does it have, this one has 2 solutions, and they're both imaginary. So 2 imaginary solutions, one positive 5i, one negative 5i. This one has 2 solutions, and they're both imaginary. Positive 4i square root of 3 and negative 4i square root of 3. Okay. 2 more on this page. Solve this for x. So we have to first solve for x squared. Subtract 96 on each side. 3x squared equals negative 96. Divide each side by 3. X squared equals negative 32. And now take the square root of each side. Positive and negative on the right. So x equals positive and negative square root of negative 32. And then simplify that using a list of perfect square numbers on the first page. It's going to be 16 times 2. And we still got that pesky square root of negative 1. Square root of 16 is 4. Square root of negative 1 is I. So 4i square root of 2. And the last problem. 9x squared equals negative 25. Solve this for x. So first you have to solve for x squared. So you have to get x squared by itself. So divide each side by 9. X squared equals negative 25 divided by 9. Now take the square root of each side. Positive and negative on the right. So we have x equals positive and negative, square root of negative 25 over 9. Okay. Let's take out the negative 1, and let's write it like this. X equals positive and negative, square root of 25 over 9, times square root of negative 1. And you can actually break apart this square root, okay? So you can write it like this. I'm going to break that apart, and I'm going to write x equals positive and negative, square root of 25 divided by square root of 9 times square root of negative 1. Because the square root of 25 is 5. The square root of 25 is 5, and the square root of 9 is 3. And then we have the I at the end. Okay. All right, one more problem. That one wasn't too bad because this number right here, 9, that was in the denominator. Denominator, 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 denominator. So that was the perfect square, so it easily became 3. That is not going to be the case in the last page. Okay. So you notice how there's nothing else on this page because this is a long problem. So first, you want to solve for x, so we have to solve for x squared first. So divide each side by 5, and you get x squared equals negative 49 divided by 5. Now take the square root of each side. Positive and negative square root on the right. Okay, so this becomes just x on the left. On the right, we have positive and negative square root of negative 49 over 5 still. Let me take out the negative, okay? I'm going to take out the negative one now. I'll just write it first. You can put it second if you want for now. Take out the negative 1. That's what I have right now. Okay? So far, I divided by 5 in the first step. Then I took the square root of each side. So it just became x. And then I took out that negative 1 right there, and I wrote it like that. Okay. So where to go from here? Well, let's write that as I. Let's do that next. Get that over with. And now let's break apart that square root. So let's say x equals positive and negative. We have I. And let's break apart the square root to look like this. Square root of 49 over square root of 5. Now in the last problem, these were both perfect squares, so we just simplified them and it was nice and easy. This time that's not the case. Okay, it's not the case. But the top one is easy to simplify. You can simplify that to 7. Now, I'm really multiplying these together. So if you want to think of this as being I over 1, when you multiply these together, you get 7i over square root of 5. Okay. As the lights go off in the room, hold on. Good. Now, here's the problem. This is not a perfect square. And you cannot leave a square root in the denominator. You cannot leave a square root in the denominator. So what you have to do is you have to rationalize. Okay? What that means is I am going to multiply by whatever this is over itself. So I'm going to multiply now by square root of 5 over square root of 5. Whatever this is, since it's not a perfect square number, you have to multiply by this over itself. So I'm multiplying by square root of 5 over square root of 5. Why am I doing that? To get rid of the square root in the denominator. Okay, so here's what I have. You're multiplying fractions. Okay, so we still got positive and negative. Multiply the numerators together. 7i times square root of 5 is going to stay like that. But when you do the square root of 5 times the square root of 5, you should know right away that becomes just 5. The square root of any number times the square root of the same number is just the number without the square root sign. So now there's no square root in the denominator. Okay, so we took care of that. See if you can simplify this anymore. If you have like 10 over 5, you would simplify that. If you have like 15 over 5, you would simplify that. But you can't simplify 7 over 5. So this is the final answer to that pretty tricky and difficult problem. Okay, and again, the reason why you had to do that was because the square root in the denominator had to be removed. You cannot leave a square root in the denominator. Okay, so that's a tough problem. Okay, so again, you need to make sure you have these list of perfect square numbers memorized. It will be much easier for you to do problems from this lesson and the upcoming lessons if you have those perfect squares memorized. Okay, and that's the end of that lesson, solving quadratic equations with square roots.